Today, we're diving into one of the biggest, thorniest problems in all of AI, memory. We're going to break down the race to figure out how these models remember, and more importantly, why they forget, and what solving that means for all of us.
You know the feeling, right? We've all been there. You're having a great back and forth with a chatbot, you give it a key piece of info, and then, a few messages later, poof, it's gone. The AI has absolutely no idea what you're talking about. This isn't just a small glitch, it's a massive technical hurdle, and it all comes down to something called the context window.
The easiest way to think about the context window is like this. It's the AI's short-term memory. That's it. Everything you say to it and everything it says back has to squeeze inside this limited space, and once it's full, the oldest stuff just gets pushed out and totally forgotten. It's kind of the digital version of walking into a room and having no clue why you're there.
Okay, so the obvious solution seems simple, right? Just give it a bigger memory. Make the context window huge. Well, it turns out it's not that easy. In fact, you run into this crazy paradox where making the memory bigger creates a whole new set of even bigger problems.
And I mean, just look at these numbers. They are absolutely staggering. A token is just a piece of a word, and for a model to handle 1 million of them, that's like a really, really long book. The cost just explodes. We're talking 125 gigs of expensive GPU memory and nearly half an hour just to generate the next single word. It's a total computational nightmare.
So knowing that this massive cost barrier exists, how is anyone building AI apps that actually work today? Well, it all starts with a bunch of really clever tricks and workarounds that developers use.
On one side, you have the most basic approach. Just chop off the old stuff. It's called truncation. It's fast, it's simple, but you're always running the risk of throwing away something really important. But on the other hand, you have a much smarter approach called Retrieval-Augmented Generation, or RAG. Instead of trying to cram everything into the AI's short-term memory, RAG acts like a librarian, finding and pulling only the most relevant facts from a huge knowledge base exactly when they're needed.
And the toolkit is getting bigger all the time. Developers are using things like memory buffering to save important details from a chat, or hierarchical summarization to take a giant document and boil it down piece by piece. There's even context compression, which automatically snips out all the fluff. It's really a whole bag of tricks to manage memory.
But let's be real, these developer tricks are kind of like putting a bandage on the problem. The next layer of the solution goes way deeper. It's about changing the fundamental design, the actual architecture of the AI models themselves.
One of the huge innovations here is called Grouped Query Attention, or GQA. So in older models, different parts of the AI's brain all worked independently. GQA is way more efficient because it lets groups of these parts share resources. You can think of it like carpooling for neurons. It cuts down on memory traffic like crazy, without really slowing things down. It's a brilliant idea, and now it's basically the industry standard.
Then you've got Mixture of Experts, or MOE. This is so cool. Instead of building one giant brain that tries to know everything, you build a whole team of smaller, specialized expert brains. And for any given question, the AI only calls on the 2 or 3 experts it actually needs. This is how a model can store a massive amount of knowledge but stay super fast and efficient. It's like having a giant library, but with the speed of a cheat sheet.
And here's another clever architectural hack. Just limit the AI's focus. It's called sliding window attention. So instead of making every word in a document look at every other word, which is computationally insane, this method just has words pay attention to their local neighborhood. It's a simple change, but it has a massive impact on cutting down the work the model has to do, especially with really long texts.
Okay, so we've covered developer tricks and smarter model designs. But then you have the researchers. These are the people who are just completely rewriting the rules of the game from the ground up.
This quote I saw from a developer discussion online just nails it. The future isn't about making memory bigger and bigger forever. That's just brute force. The real quantum leaps are coming from finding ways to be smarter, not just bigger. And this graph right here, this is the aha moment. This is the key insight. What it shows is that for any task, the AI only needs to focus on a tiny, tiny fraction of all the information in its context window. Almost everything else is just noise. This discovery is called attention sparsity, and it changes everything. So if you know that most of the context is just noise, what do? Well, that insight leads directly to radical new ideas like retrieval attention. Instead of brute forcing its way through every single token, the model uses a super-fast search to instantly find and grab only the few critical tokens it actually needs. It stops reading the whole book and starts using a perfect index instead.
And you know, researchers are attacking this from all sides. It's not just about changing what the AI computes, but also how it computes it. A technique called flash attention 2 doesn't change the math at all, but it completely redesigns how the calculations run on the computer chips, making the whole process up to 2 times faster. So what does all this research, all this brain power get you? It gets you numbers like this. We are now seeing models that can handle a context window of over 2 million tokens. We're not talking about remembering a single book anymore. That's an entire series of books held in memory all at once.
So what's the big takeaway here? Where does this all leave us? Well, the solution to AI's memory problem isn't one single thing. It's not a silver bullet. It's a whole stack of innovations all working together.
You see, it really is a multi-layered solution. We're solving this memory problem on 3 fronts at the same time. At the top, you have developers using clever hacks in their apps. In the middle, you have architects building more efficient models from the ground up. And at the very bottom, you have researchers who are fundamentally changing how attention and memory even work.
And all of this leads to a final, pretty profound question. As these AI models go from forgetting what you said 2 minutes ago to having a near-perfect memory of millions of pages, what does that really change? I mean, if an AI can remember every word of every book ever written, what does it actually mean for it to understand any of it?